So yeah, carrying on from the previous video, this was the experiment 1, and we see on the left we have a TTO accuracy graph, and on the right we have the different waveforms that have been represented here. So experiment 1, ERP results P1 and N1. So the goal was to determine whether attentional blink affects early perceptual processing. So we are talking temporally, time-wise, right? So what they found, firstly, ERP waveforms on the right panels plotted for frontal, parietal, and occipital electrode sites, and it compares dual target condition versus single target condition along the x-axis. We have the different lags 1, 3, and 7. Right, you can see here. And the result was no significant difference in P1 or N1 amplitude or timing across conditions or lags. Interpretation: stimuli T2 probe are still perceived P1 and attended to spatially N1, yet they don't make it into memory at lag 3. This points to a post-perceptual bottleneck that is during consolidation. Final inference: attentional blink is not due to a failure in perception or early attention. Instead, it's a failure in transferring info to the working memory. The brain can see and process the second target, it just can't consolidate it. And this is because of the fact that we have lesser attentional resources, since our attentional resources are actually involved in focusing on the first target that appeared. Now you can go to this. This is our table, but we'll move on to experiment 2, which is this one. So again, to investigate whether semantic processing of a word T2 still occurs, which is target 2, still occurs even if the word is not consciously reported during the attentional blink. Right. So stimulus types: context word T1 presented for 1000 milliseconds, which is the second example, shoe or pickle, followed by a series of distractors, nonsense strings. Later, the target word T2 is shown in red, could be semantically related to the context word shoe and sock. Unrelated, it could be unrelated, shoe and mustard. Right. So what we do is, again, compare the dual task versus the single task. So dual task, the main experimental condition, task 1 was to judge if a number is even or odd, and task 2 is determine if the red word T2 is semantically related to the context word T1. This setup is designed to induce attentional blink. And single task, again the control one, only perform task 2, which is determine if the red word is semantically related to the context word, which is T1. So only perform task 2, semantic judgment, no AB, attentional blink expected here because attention isn't split. So our attentional resources won't get confused whether to attend to this or to that. You just have to focus on the semantic judgment of the words T1 and T2. Now, purpose to examine if semantic meaning of T2 is still accessed even when it's not consciously reportable during the attentional blink window. So the results, you see, one sentence here is given as: he's got in the car and turned on the mustard. He's got in the car and turned on the radio. Right. So late ERP component, this one, corresponds to semantic processing. So the results: N400 component. So we'll go over this in depth. So ERP component N400. A negative going ERP wave peaked at 400 milliseconds post stimulus. Here you can see at 400 milliseconds post the stimulus, evoked by semantic incongruity or mismatch. For example, he got in the car and turned on the mustard evokes a large N400, while the sentence he got in the car and turned on the radio, which is semantically correct as well, evokes a small N400. Okay. So the interpretation now: if the brain detects that mustard doesn't semantically fit, it has understood the meaning. Thus, the presence of N400, which is semantic processing, occurred even without conscious report. Right. So you see presence of N400 component, the semantic processing of the stimulus is achieved. This is the inference. So no difference in magnitude and time course for N400 component. Behavioral graph. T2 accuracy dips at lag 3, here as you can see, in the dual target condition, but remains high in single target. Alright. So ERP waveforms, locations frontal, central, and parietal again. Observation: N400 waveform is present at all lags, including the lag 3. So the inference is, although participants fail to report T2 at lag 3, which is the point where behavioral attentional blink occurs, the N400 shows that they semantically process the word. This provides compelling evidence that attentional blink is a post-perceptual suppression, that is, the word was perceived and semantically processed. It failed to be consolidated into working memory, hence not reported. Failed to be consolidated into working memory, hence not reported. So it is a post-perceptual suppression. Awareness and semantic processing are dissociable. Supports a multi-stage theory of perception, identification, semantic access, consolidation. Attentional blink blocks the last step only, which is the consolidation or report part. So yeah, that's